And here we are again. Welcome back to everyone from Brussels. Hope you've all had a good lunch and are ready to attack this final session with us. Our online audience back and fit in front of the screens. It's time to dive into the Teaching Factories competition, one of EIT Manufacturing Education's key initiatives, and it aims to promote an educational methodology by showing the benefits of academia-business collaborations in a context of manufacturing innovation. Well, I should mention that this is a first for this competition, and here's the basic premise. So industrial companies proposed a set of real-life challenges to be solved by teams of students. They came from universities and also from various vocational education and training centers, so VETs. And the 6 challenges presented were related to green manufacturing. And the companies could, of course, then benefit from the advanced knowledge and methods and methodologies currently being taught and used at those universities. So let's get Dimitris Mavrikios. He's COO of the EIT Manufacturing. Let's get him online. And a warm welcome to you, Dimitris, joining us from Athens again. Nice to see you again.
Good afternoon. Today I would say that I'm joining from a rather cloudy Paris, but we are still very excited to participate in this event.
That's wonderful. It's great to see you. Everybody's all over the place. Klaus is in Paris and Konstantinos down in Tel Aviv. Dimitris, why is it important to apply manufacturing education paradigms such as the teaching factories in Industry 4.0? Just tell us sort of why that is important as the background for this competition.
Yeah, first of all, I have to say that I have been really very happy to receive this invitation from Paula to do this opening. And it's not only because it was a milestone event for our KIC, but also because in a previous phase of my career, I was really very actively involved in research around emerging manufacturing education paradigms, such as the teaching factory. So why it is important? The teaching factory is actually a unique paradigm for training students around manufacturing topics by bringing the real factory to the classroom. That is not always possible with other kind of trainings that are in place in our universities. The teaching factory paradigm allows remotely located student teams from universities on the one side and engineering teams from manufacturing companies on the other side to work together on real-life engineering projects or challenges that come from a real production site or business working environment. And the benefit is very clear. The students on the one side can benefit by improving their sense of what is the real manufacturing challenges that they will be addressing when they will be working in a real factory. They will be able to improve their problem-solving skills and also gaining very valuable practical knowledge from their interactions with the experienced engineers from the manufacturing companies. And of course, from the other side, the manufacturing companies can clearly benefit from this approach by getting all these new, fresh ideas and out-of-the-box thinking from the students in addressing their challenges, and of course, getting in touch with talented young people that maybe in the years to come could be also recruited in their companies. Actually, Industry 4.0 technologies have boosted the potential of this initiative in the sense that they provided all the required platforms and tools that would allow a really efficient and effective collaboration and work between the student teams and the engineering teams.
And just give us an idea how many teams took part in this first edition.
Today we will be addressing, we will be expecting really with a lot of anticipation our 6 finalists to present the solutions that they have developed to the real-life challenges that have been introduced by 6 manufacturing companies. So we are all really very looking forward to that with a lot of anticipation and also our best wishes for good luck to all finalists.
Thanks very much, Dimitris. I think we had a fantastic first session with the RIS Leaders Competition, and I see no reason why this one should just carry on and be just as fantastic. There were great projects presented there. And thanks for giving us a little bit of background for our audience on this new Teaching Factories competition. And all the best to you in Paris. Thanks for joining.
Yep, thank you very much.
Okay, bye-bye. And for our audience, so before we move on to our pitches, I'll just mention that the 6 best performing teams, as you heard there, will compete for the top 3 spots with a brief summary of their results. And I'm going to do a quick introduction and a shout out to our jury because Renata Urbon is here. She is CEO and co-founder of Leaneria. She's joining us from Lithuania, I believe. Just give a wave there, Renata, so that we know which one exactly. And Virgil Pamphil is managing director of the VIP Prof Consult, and he's coming to us from Romania. So welcome to Virgil. And last but not least, our third jurist is Sima Valizade, who is CTO, Chief Technology Officer at Sandbacka Science Park in Uppsala in Sweden. And just so that everybody's aware, all of our finalists and jurors for this Teaching Factories competition are connecting remotely today. And now it is time for our pitching. The technology is always a little bit sleepy after lunch, as we all know. It happens to the best of us. So just a little bit of information for this pitching session, because each pitch will be 5 minutes, followed by a question from the jury. And with that, I have the pleasure of handing over to our very first finalist. And I would ask Philip Sentikiralyi to take it away with the first pitch. Let's see if we can get him on the screen first. Have we got Philip connected? There is Philip. Greetings from Brussels, Philip, and please take it away with your first pitch. You have 5 minutes.
So, first of all, I would like to thank absolutely everybody here for giving us this experience, and I would love to thank the jury for being here and listening to us. Now, if we can get to the presentation, there we go. So, next slide, please. So, we worked with Arne Plant for the challenge of, next slide, manufacturing shoe insoles towards a zero waste policy. We came up with a revolutionary idea that we will explain in a few minutes. So next slide, please. So these are my teammates, Fran Đurić, me, Filip Sentkiralyi, Damir Narančić, next slide, Maria Vinoncic, Lorena Bielic, and that's all. Next slide, please. So first of all, timeline of our participation. In April, we started working on the idea overall. In May, we basically got the idea down, what we wanted to do. In June, we researched it more into various topics. We discussed maybe different ideas, and finally in July, we finally refined our final idea, which is, next slide, 3D printing, a revolutionary way of producing shoe insoles. Next slide. So first of all, we need to explain what exactly is 3D printing. 3D printing is a process of constructing real 3-dimensional objects based on digital 3D models that are done by different softwares. And objects are constructed layer by layer under precise computer control. Increasing speed and cost effectiveness in recent years have made this method absolutely viable for wider scale manufacturing. And 3D printing is now being used to produce consumer products, dental products, industrial products, and many others. One of them being a whole bridge that's been in Amsterdam, a footbridge that's fully working, made out of steel. Absolutely incredible. So the process of 3D printing. So first of all, we need to create a 3D model in some kind of software, which either can be downloaded or is actually offered by the 3D printer. And then next is the splitting process, which the 3D model is split into layers. And printing process, we choose the material with which we want to print. Then the thin nozzle spray basically works in the work area, spraying it layer by layer. And of course, finished product, after everything is finished, it can be further refined with the different types, maybe 3D printing, maybe handcrafting, and so on. Next slide. So this is a short video. So basically, how you see first, we start off with supports that are actually going to support our full product, which here is a shoe insole. This lasted about 3 to 5 minutes. It's pretty sped up, and this is about a middle-sized 3D printer. Of course, we can do much better than this printer. And as we will see in the second, there is a short quality test to ensure that the insole actually works as it's supposed to. As you see, it's bending in the middle. It's fully completed. It has texture and absolutely everything that you can wish for. Next slide. There we go. So the advantage of 3D printing. 3D modeling using computer software allows for a high degree of precision when designing the shoe insoles, which can be changed at any point in time. 3D printing is an additive process, and it only uses the exact amount of material needed for the product, resulting in both waste reduction and higher cost efficiency. A wide array of materials are available with a spectrum of specific qualities. Most of the materials are both biodegradable and easily recyclable, which is quite revolutionary in my opinion. Less energy is consumed, and basically no harmful emissions are produced during the manufacturing process. And of course, we have the production flexibility. Each model can be easily downscaled or upscaled depending on the needs, with many potential ways to improve existing processes or to create completely different services. And to summary, basically, 3D printing is already a fast-growing method of production, and many further technological breakthroughs can be expected in the near future. In 2015, a 3D printer cost around over 20,000 euros. Right now, it's around 5 to 10,000 euros, which is over the double the price. 3D printing offers a viable way to massively produce products, all by reducing waste, energy consumption, and being environmentally good. Digitalization of the manufacturing process allows for a more detailed analysis, more specific and custom designs to better satisfy the needs of the customer, and high flexibility when it comes to changing the manufacturing process itself.
Stop you there. Thank you very much. Wow, that was just about a Punktlandung. Thank you very much for that explanation of your project and the challenge that you had to solve. And now a question from the jury. Let's bring the jury onto the screen. Exactly. And do you guys have a question ready for Philip after that interesting presentation?
If I could start with the questions. Does the speed that printing offers satisfy the needs of the manufacturing company that give you the challenge?
While it is a bit slower than their normal current one, it's actually pretty fast. Usually, the highest end 3D printers now offer up to 300 millimeters per second of 3D printing.
Thank you for that question. Are there any other questions from Virgil or?
Well, just a brief questions about do you have previous experience in using this technology in the school, in the university?
In the university, not as much, but in personal life, yes, I do. I've 3D printed different. Actually, I'm 3D printing a shoe, a helmet, and figurines.
Thank you.
Sima, we can't hear you. You're going to have to unmute your microphone.
Yes. Okay, sorry. Yeah, thank you very much, Philip. It was very interesting. And I want just to ask you, this type of printing, shoes and soles, is very popular today. And why you think the things that you are doing today is innovative?
How you see currently, not many companies actually use 3D printing to 3D print their products, even though it's viable. Some companies do, like different medical companies actually use 3D printing to print their shoe insoles, but those are really expensive due to the high precision of each shoe insole and need for the person. It's usually not used in bigger scaled companies, which is pretty sad, in my opinion.
But I have bought one shoes for my son. I think it is very popular.
With the youth it is, but with companies
Yes.
not as much.
Thank you.
Thank you very much, Sima. Thank you very much, Philip Santikiral and his team of solvers. Thanks for joining us from Croatia. And we'll get back to you later after the jury has deliberated. And we're going to move on to our next finalist. And our next finalist is Fotis Basamakis, who I believe is joining us from Greece. So Fotis, let's get you onto the screen here. I think we've got him waiting in the wings.
Hello, everyone.
We can hear you. Let me see if we can actually see you, Fotis. There you are. Take it away. You've got 5 minutes. And welcome.
Yes. So, hello, everyone. My name is Fotis Basamakis. And today I'm going to present you the University of Patra's proposed solution regarding the Protosfera challenge of the Teaching Factories competition. My teammates with whom I'm inside the framework of the present competition are Baboula Xanthi, Porevopoulos Nikos, Glikos Christos, and Manetas Christos. So, the contents of this following presentation are as follows. First, there will be a short introduction of the challenge that we attempted to overcome. Then, alternative approaches that are used in the literature to address similar problems will be presented, followed by our selected approach and hardware for this specific problem. Next, the implementation will be analyzed, and for the last, some results and limitations will be displayed. So the challenge that we attempt to address is basically the implementation of a quality inspection system for additive manufacturing procedure. The system must be able to detect at least 4 out of 7 common 3D printing defects. Those defects are the layer shifting, low bed adhesion, stringing, spaghetti, warping, bridge separation, and extruder clogging. The proposed solution must offer online monitoring of the 3D printing process in order to be able to stop it if a defect appears. Detecting a defect is very valuable to green manufacturing, since by stopping the procedure, which could take up to several hours to finish, operation time and energy consumption are reduced, and also the produced waste is minimized. So for moving on to the alternative approaches, a motor recorder could have been used in order to detect the defect of layer shifting. The motor encoder provides continuous position detection. So if a stepper motor misses a step command, then an algorithm can implement it to compare the difference of the two positions and therefore detect the defect. However, since it's not a universal solution, customization is required for every 3D printer, so it's not recommended. Another possible solution is a computer vision-based templates matching approach between a layer shifting object and the corresponding accurate template of that object. However, due to limitations like sensitivity to the object translation, this method is also rejected. Our selected approach is a hybrid solution that combines 2 different techniques, the filament sensor and the object detection framework. The filament sensor can be used in order to measure the consumption from the printer and detect the defect of the nozzle clogging. That particular sensor will compare the filament consumption from the G code with the actual filament consumption on the nozzle and display an error when they don't match in the event of filament clogging on the nozzle. It is worth mentioning here that in order to implement this approach, an external addition of the filament counting sensor module is required, and therefore there will be a small customization on the 3D printer. Our other approach is a computer vision-based approach, which, according to the literature, offers the widest variety of object detection, of defect detection, while also combining affordable hardware. In our case, we used object detection in order to detect 4 out of 7 defects. Those are warping, stringing, bridge separation, and spaghetti, as you can see in the current slide. The key concept of this solution, apart the low cost, is that it is not invasive because it's a computer vision approach, and it is highly accurate and flexible in the sense that it can be used for different defects without any modification. As for the hardware, 2 low-cost web cameras are utilized, and the positioning of them will be such that offers the optimal field of view. For the model, we propose the state-of-the-art 5th version of the YOLO object detection framework that basically utilizes convolutional neural networks in order to provide automatic object detection as well as a classification on images. To achieve the identification of a specific object, YOLO performs a classification of objects into groups based on some special characteristic existing in the image that are called features. Those may be different structures in an image, such as point, edges, or whole objects. For the training of the model, a total of 40 to 50 images per defect collected and labeled manually. For the labeling, a Python-based annotation tool used, and also various data augmentation techniques implemented in order to enlarge the dataset and provide more robustness to the outcome of the model. For the evaluation of the model, we use the mean average precision metric, which represents the area under the precision recall curve. The bigger the area, the better the model, and our model scored 0.8. That basically means that it correctly detected 80% of the objects of the evaluation dataset.
So I'm going to have to stop you there, Fotis. Your 5 minutes are
Okay.
up. Sorry about that, but we'll get the jury on the screen here. After that presentation of the Protosfera challenge from Fotis Passamakis, take it away with questions. And you have 2 minutes, so I would ask you to be quick and make sure you have your microphones on, please. Thanks.
Thank you very much for presentation. What effect will your solution bring to the company? And how much does it cost, like cost versus effect?
It's basically our solution is able to detect 5 out of the 7 defects presented from the company, and the cost is incredibly low. Like we only need 2 cameras, web cameras. It's pretty cheap, and the filament sensor is also really cheap. So I guess it will offer good analogy between the cost and the outcome.
Other questions, possibly from Sima?
Yes, thank you. I want to know, did you compare your technique with digital twin method? Because digital twin is much more faster than the method that you are explaining, CNN, if I am correct. Then what do you think about the time consumption to do this type of detection image?
YOLO is really fast model. It operates in real time, and I think that it's basically able to detect objects in milliseconds in an image. So I guess the time response is really good of the model. It's tested as well. You can see the model in video frames, like 30 FPS.
Okay, thank you.
Thanks very much. I think we're going to have to stop there because our seconds are literally running down. Fotis Passamakis and your team of solvers in Patras, thank you very much for being here to represent this project. And congratulations on being a finalist. And with that, we are going to proceed to our next finalist, whose name is Teodora Tanchevska. And I would hope that we can pull her up on screen and then give her a start. There we are, Teodora. Hi, greetings from Brussels, and you've got 5 minutes. Take it away. The floor is yours.
Okay, thank you. Sorry, I cannot see the presentation. Just a moment. Okay. So our challenge was with Geavio, aeroplane company from Italy. Our challenge was to find a way how to reduce the energy consumption and to find a solution for greener manufacturing in aeroplane industry. The next.
Oops. Can we get Teodora back? Let's just see.
Okay.
There she is. I can hear you, Teodora.
I have a problem with, I'm so sorry, I had a problem with my connection.
That's okay. So carry on. I'm going to give you a couple of seconds grace for that. Don't worry.
Okay. The airplane industry is responsible for producing a number of aircrafts, helicopters, satellites, and etc. On the next slide. Can we move to the next slide? So this is our team, consisted of Damian, Michaela, Daniela, and me. On the next slide, we have a small agenda, the introduction to the problem, our two suggested solutions, and the conclusion in the end. So as IM students, on the next slide, as IM students, we focused on software solutions and digitalization of the process. As I mentioned, airplane industry has a number of aerospace products like civilian airplanes, military airplanes, satellites, space vehicles. On the next slide, we have how did we come up with our ideas? We are facing an energetic crisis, so we must think for energy reducement. So we focused on digitalization of the process and synergy. On the next slide, we have the synergy is a system that is designed to control, to report, to optimize, and to monitor the use of electrical energy in one company. On the next slide, we have what synergy means. It means optimization of the process with optimizing the use of electrical energy. It provides continuous measurement of the electrical power, so each machine will have we will know how much energy each machine uses. On the next slide, this is what we recommend. Each machine should have a device or inverter that will monitor the levels of energy consumption. On the next slide, we have another solution. We thought of implementing some kind of software on the machines that will be smartphone based, so the operators will use it really easily, simple and user-friendly. It will provide a customized speed of the machine, and it should be standardized so that it will be implemented on each machine. Benefits of the synergy and the software solutions, we will save some money, and we will reduce the energy consumption, especially in the times like this when we have energetical crisis. Thank you for your attention. Do you have any questions?
Well, there you go. You ended up finishing well under time, even with the technical glitch. So thank you very much to Teodora Tanchevska. And let's get our jury back on the screen here. And Sima and Renata and Virgil, one of you must have a question.
Yes, of course. Thank you very much for the presentation. Could you please explain additionally, did you consider developing such a system, or do you consider selecting some of the already existing systems on the market and deploying for the manufacturing company that gave you the challenge? And if you decided to develop, then what kind of innovative features would your system have compared to those available on the market?
Thank you for your question. So we thought that we will not invent this inverter. Actually, we will find a company that makes the inverters and suggest them to the company like Geavio to implement on their machines. Because we don't make the inverters. We will buy them from the market.
I have another question here, and how can you complete your software to measure the noises, or even look at to the shape and design of this type of engine? Is it possible to make some sort of complementary to your software program?
Sorry, can you repeat the question, please?
I just wonder if your software program could be able to do some sort of measurement for noises when you have in the engine, if you are talking about green manufacturing, or which type of characteristic or analysis you can do by your software.
Actually, the software will monitor the energy consumption, not the noises of the machine.
Okay,
just
but
the
it is related, yeah? It should be related to noise, or? Okay, yeah.
And I think we've lost Teodora once again, but we've come to the end of that question period anyway. So thanks very much to her for presenting the challenge that was posed by Geavio for greener manufacturing in the aerospace industry. And with that, we can proceed to our next finalist, who is Daniel Todt, who's joining us from Hungary. And I think he's online, hooked up and ready to go. Welcome from Brussels, Daniel. We're glad to have you. And take it away. You've got 5 minutes.
Thank you very much. Then, dear audience, dear jury, my name is Daniel Todt. I'm the president of Team EIT from Hungary. Let me welcome everyone on behalf of my team. Actually, our task was given by Intellimech to make a system for a copper wire drawing line, which are capable to monitor the quality of the product in real time with a non-destructive way without stopping the line. Next, please. Before I present the solution for the task given, let me introduce our team members, namely Horváth Bálint József, Horváth Kristóf Tibor, myself, and on the next PPT, Ag Martin and Bódi Vanessa. Next, please. Let's evaluate the current system. The copper wire production technology starts with the base material, which is copper wire, but of course, is a lot thicker than the finished product. We will draw the material through smaller and smaller diameter dies until we reach the required diameter. After we strand the wires together if we need, coat it in insulated enclosure, then the last quality check, then the product is finished. Next, please. On this illustration, we can see the line for the first part of the production technology, the drawing. We can see that there are 16 dies, each paired with the caster. And at the end of the line, we storage the finished wire. During the process, the wire gets continuously lubricated to reduce the friction. Right now, the diagnostic system requires to stop the line and put the measuring unit over the line to get the needed information in a static way. Next, please. That is the part which is undesired now and for which we made a solution that we thought would be the best, taking into account the principles of Industry 4.0. For first, we needed to determine which parameters we need to measure. Two parameters are given from the start, which are the diameter and the die diameter and the pulling force. The target value will be the diameter of the wire. To be able to find some correlation between the given parameters and the desired diameter value, we installed vibration and temperature sensors at every die. With the help of these sensors, we can follow up the wear on the dies. At the end, we installed a monitoring unit which consists of an air blower to clean our wire out of the lubricant that we used and any other kind of contamination. After that, there is a stabilization zone followed by a thermometer and a diameter measuring sensor. With the help of these sensors, we can make the quality check online, which means that we won't need to stop the line for it anymore. The thermosensor at the end is essential because the copper can expand depending on the temperature. So we'll need to make correction based on it. Next, please. For the vibration and thermosensor that I mentioned, we found Ron's intelligent wireless CMS with 16 sensor pairs and the control unit. And because the system is wireless, it's much easier to install. For the air blower, the Epitech adjustable spot cooler on which we are able to change the head out if we need. Next, please. Because we didn't want to use tactile sensors for the purpose of the diameter and the thermal measuring, we found these two sensors for our solution. The first is the 2-axis laser diameter sensor, which we are able to measure circularity as well, not just diameter. And on the right, an infrared thermometer. Next, please. We collected the prices of the mentioned parts as well, which cost roughly 10,000 euro overall. But of course, currently the prices of the sensors and the electrics are unpredictable, so as the stocks of these products as well. So please take these as information purpose only. As we can see, the most inexpensive part is the vibration and thermosensor system, where we'll be able to reduce the cost if we halve the sensors, so 8 instead of 16 if needed. Next, please. We made an illustration how the measuring system would work. We would collect the data from the line with the help of the sensors and the CMS, which would be then sent to a local or remote server. But from the local, we will send it to the remote server as well later. And if everything goes out of the tolerances, we can immediately stop the line and notify the corresponding personnel. Next, please. We made a model of the monitoring unit, which is at the end of the line. Here we can see the spot cooler with a double-headed end. Next, please. We gathered some additional ideas for the future, which I would like to present just shortly. The first is for search trends and correlations in the collected data. Then, by the help of machine learning, make predictions based on it. And the other one is to connect the individual system of the lines together, if you have more lines, of course, with the distributed controlling. Next one, please. And on the last slide, we can see a comparison between the current and the suggested system. Both of these are non-destructive, but ours can make the diagnostics in motion, in continuous, and it will help us to make more efficient maintenance planning. Next, please. Thank you very much for your attention and attendance. Please feel free to ask questions. I will try to answer them to the best of my knowledge.
Thank you very much, Daniel. Your thank you slide came to the second, so we're going to pull up the well done, and we'll pull up the jury. Here they are. And jury, feel free to take a stab at who's going to ask the first question to Daniel.
Yeah. May I start? I want to ask you, are you able to measure strain for the wires or cable? Strain.
No, we did not thought about that.
Okay. Because
actually,
it's also important, Yeah.
Oh, I see. We actually was given to that the diameter will be the most important parameters to measure.
Okay. Yeah, thank you.
Thank you very much.
The cost that you have estimated, I noticed is mostly for the equipment. On top of that, I think software development would need to be developed, and that would cost for manufacturing company as well. Some euros, some thousands of euros. Did you consider that? And the other part of the question, what's the effect of your solution for the manufacturing company? What's the impact?
Actually, I will start with the impact, if I may. Actually, the impact is that they don't need right now they are using a machine much like that we modeled, but they have to stop the line and get the machine to the line, and it takes a lot of time actually. So they can make more wire in a normal day than with their kind of system. For the other part, we thought about there are a lot of existing program on the market, and we thought that we should use some kind of program that are already given, licensed buy them and use them.
Did you select some solution to offer for the company, or this shall be decided by the company on a later stage?
We looked up some, but actually we did not put in the presentation. But I don't really remember right now the names of this kind of software. Sorry. Thank you very much for the question.
Okay, and thank you very much for the presentation, Daniel Todt, and thanks to the jury for those, once again, extremely detailed questions. And you can tell that they are listening and on the edge of their seats for these presentations. And we're going to go on to our next finalist, our next to last finalist, Simon Kanka. And let's see if we can get Simon up onto the screen. There you are, Simon, we can see you. Welcome from Brussels, glad you could join us, and you've got 5 minutes. The floor is yours.
Good afternoon, everybody. I'm from Pisa University, and our problem was about clean air, so more for office things and to clean the air. And the important thing that they wanted to make is to pay attention to the noise, because a noise environmental in an office could worsen all the condition for healthy of the workers. So this year's the team. It was a different kind of studies. Everyone has a different path of university. Next slide, please. So the first thing we did was to take the whole mechanism and to disassemble it to see where the important things, where it is most important to work, because in the noise you have different frequency responses, like we can see in the next slide. And we can see here the using of the acoustic camera. The acoustic camera is a new innovative method. As in this case, it has 75 microphones array that can help us to see where the biggest noise intensity levels are and which frequencies fails. And we can see here it was a problem with the water pump that was in the lower region of this emplacement total reconstruction. Next slide, please. So we began to work in this problem with two different kinds of implementation. The short ones that could, and we will see, lowered from 5 dB the overall level. 5 dB is seems like a small number, but it's a really big number. It can really take from healthy situation of noise to bad situation of noise, and to long implementation that will be after studied. Next slide. Here are the different kind of spectra, so the frequency spectra of the noise emission with the different short implementation kinds. The short implementation kinds work with the pump, because at the beginning it was like we're breathing the overall system, and the noise emitting because we have the plant system that has different kind of escape for the air, so that can depurate the air in the office. And so we put some porous material there, and the ventilation above that needs to take the air from the office or in the air condition, then bring it down so that it can be depurated and then bring about again in the overall room. Next slides. So the long-term implementation was to find the best nozzle for the pump, because this system was very noisy. And so we tried to find the best ones, and this will be another long implementation. Next slide. And where comes the eco-friendly kind of solutions? The eco-friendly kind of solutions can come from the construction of all the system with wood glass, or for this porous material that can be made from mushrooms. Not the mushroom, but the earth where the mushroom live. And it helps very much because it can filter the air and can so mitigate the noise, and it has a metal structure. This can be made with media material for the ventilation system that's above, and that doesn't need the only important thing is the geometry of the overall construction. So to mitigate the noise level that will be going produced from this overall machine. Next slide, please. So in summary, we will need more studies for this thing, because we saw where the biggest frequency problem was, and there are new solutions that are to bring the frequency for resonance of elements to lower frequencies where the human ear are not able to hear it. And it does not bring any damage to the human from different studies you can see. And so we are very happy that we can find, at the lower level from 5 dB of the overall machine with elements that was found in our laboratory. So we didn't ask anything to the manufacturing company, and we found really fast solutions to mitigate the overall problem. Another solution that will be needed is to see the implementation of all these elements in the room, because we know that the room can have different problems, and the noise emitting depends very much of the position of the elements. Next. Thank you very much for your attention, and I'm happy to hear any questions.
Thanks very much to Simon Kanka. Also under time for that interesting presentation on the challenge of noise reduction in a plant. And let's bring our jury back on screen. There we are, and take it away, Renata, Virgil, and Sima.
I missed my round. So may I ask, do you consider making a business from this by measuring emissions and implementing silencers?
Yes, a lot. There is very much of the industry that's going in this way, because until like 20 years or 10 years, it's a very new, innovative kind of aspect. It has been neglected, the noise problems that arise for the health of the people and the workers more specifically. So there are more and more arise the consciousness that it should be looked good on the noise. Like if you have a noisier room, think in an office, then the efficiency goes down, the workers get bad. So it's overall the problem, the noise. It's not so, and it's healthy.
This is obvious, but do you consider starting a business on this? Your team, I mean, did you consider this?
At the moment, I'm working on a PhD thesis for lowering the noise produced by the tire pavement interaction. So yes, I hope that I can go further with this research.
Thank you.
Thank you.
May the company, manufacturing company, use and utilize your solution straight away, or it will need the additional research that you have mentioned?
No, they can use the solution right away. It's the additional solution will only be for more eco-friendly and sustainable solutions. But this one just brought down from 5 dB the overall noise, and it was in accepted levels for the normatives.
Thank you.
And I think we can stop there after 2 questions from the jury. Thanks very much for those questions again, and to Simon Kanka and his team of solvers at the Pisa University in Italy. And finally, we are able to give the floor to our last finalist in our last presentation. And I would like to give it to Josu Najera, if we can pull him up onto the screen. Let's hope Josu is connected. There he is. Josu, hello. Turn your microphone on. Welcome from Brussels. Yeah, we can't hear you. Now we can hear you. Wonderful. Nice to see you and hear you. And you've got 5 minutes. Take it away. The floor is yours.
Okay, hi, I'm Josu Najera, and now I'm going to make a presentation about the challenge offered by a well-known company, Procter & Gamble. This challenge consists of developing an affordable solution to measure and analyze collected data of different resources such as water or electricity, and then inform relevant person if any anomalies are detected. Next slide, please. Okay, this is my team. Araite Gaña, Marina Galindo, Eneko Melendo, Equiperoids, and me, Josu Najera, and we came from Mondragon University. Next slide. This is the index I will follow. First of all, I will explain the importance of early action, then the market situation and our compromise, then the analysis products, project characteristics and conclusions, and finally the future developments or possibilities. Next slide. Okay, nowadays, as we all know, the availability of raw material is getting critically low. Therefore, we need to reduce the different resource consumption. And like that, we will minimize the earning loss. We will also minimize the environmental impact. And next slide. To start with the challenge, we first make a small research about the market, and we see that there are different solutions. So our compromise is to use an affordable solution, then to choose a software that makes simultaneous analysis, and also it detects immediately the anomalies, and finally, a software that creates a document for future reference. This is the products selected. According to the hardware, we have chosen MyRio because we think that is the most potential one. It works in different voltages, and it has many digital and analogic input and outputs. And moving on to the software, we decided LabVIEW because it offers us like a visual screen like HMI without needing to pay any extra license. This is the project design. We will read different resources from the machines. This will be read by MyRio by analogic input. Then MyRio will be connected to the computer where do we have the software there. And if the software detects any anomaly, it will send an email to the person responsible. This is the screen of any consumption. It could be water, air, or power. Moving on to the next one. This is the email data where the person responsible of the machine must enter his data so that it will receive the email. In the next screen, it shows the software error panel. If there is any error, you can search it here. This is a video. Well, I don't know if it works. This is a video. I don't know if it works, but this is a video of how it will work. Yes, you can see. The person responsible must enter his personal data and also the historical data of the resource. Then run the software, and it will obtain, as you can see, the upper and lower limit, and then it will start comparing the data read at the moment with the upper and lower limit, and if it surpasses the upper or even the lower limit, it will send an email with a TXT document about the anomaly data. And the person must start fixing the problem or the machine. Moving on to the next slide. This is the project characteristic and conclusion. Mention that we are within the budget because our first budget was 5,000 euros and our new one is 608 euros. Then we need less than 1 day to install, so we don't need any specialized worker. Then we can analyze up to 12 different resources simultaneously, and also we have designed an immediate and effective response to any machine error. And the last slide, here we can place a light tower on the machine by a digital output from the MyRio, and like that we can aware the person responsible of the machine without needing to check the email. And thank you for listening to me, and if you have any question.
Terrific. Thank you very much, Josu. And I'm sure the jury does have some questions. So let's get Renata and Virgil and Zima back here on screen. There we are. all of you together and take it away. You've got 2 minutes for questions.
Yeah, I have one question. Do you measure the average error of power by your system, your monitoring system, and the normal one? Did you make any average error in your measurement when you compare it with the existing system?
No, we just have read the historical data of the power because these historical data are good data. So we didn't read any. I don't know if that's the answer or.
Yeah, I can ask you another one if I have allowed to do that. Do you also can you give some guess how much your system could reduce the amount of power using by your monitoring system? That you should know. No, okay. Thank you.
You mentioned there are 12 variables that you are measuring.
No, that we can measure by using my real hardware. With that hardware, we can measure 12 different variables because it has 12 analogic inputs.
And the last question, if I still may, what are the innovative features, characteristics of your solutions compared to those available on the market?
Installing, as I mentioned before, installing the light tower. And then also another one could be to predict the anomalies, because we now just we are comparing the data read at the moment with the upper limit. But it will be amazing if we predict when an anomaly will occur, so that we can avoid the problem or the.
Okay, we're having a few problems with the connection there, but I hope you got the answer to at least the bulk of the answer to your question, Renata. Thank you very much for that. And with that, we've come to the end of the pitches. Thanks very much to Rosu Nachera with that challenge that they put out for Procter & Gamble. And thanks to all of our pitching finalists. Obviously, those 5 minutes go by very quickly. It's not an easy task to present that all in a coherent form. So well done. And now, of course, the jury will deliberate this information for our audience, and during that time we can find out a little bit more about the Teaching Factories initiative. So the jury is busy, and we have decided to fill that time, this time with a very short panel discussion on the Teaching Factories competition, this whole initiative. Obviously, you've seen exactly how detailed these challenges are. They're real-life challenges posed by industry to these study groups. And I would like you to welcome, we have a panel online. I'm going to ask, and hopefully they will all pop up on the screen here. Sotiris Makris is joining us from the MLS Head of Robotics. He is LMS, Head of Robotics, pardon me, Automation and Virtual Reality, and if we can get him onto the screen. Welcome to Sotiris. Giuseppe Spanto is also joining us. He's Managing Director is Clean Air at the TFC, and he is, of course, a Teaching Factories Challenge owner. And Lisa Zaccaria is the EU project coordinator at Intellimec, a company that we just heard mentioned there in one of the challenges. So obviously they are a challenge owner. And I would like to welcome all of you onto the screen. Have we got all three? There they are. Welcome from Brussels, and thank you very much for joining us for this short panel discussion to discuss the background of this new competition. So Sotiris, I'd like to start with you because you were serving as the executive director of the Teaching Factory Competence Center in Greece. And can you tell us, how does this program help Industry 4.0 in the short and medium term?
All right. First of all, congratulations for the nice work so far. I hope you can hear me quite well. And thanks for the invitation to this really interesting panel. I was really happy to see the presentations from the pitching teams. Coming to the teaching factory idea, of course, this concept has been discussed and developed over the years. Coming to the actual point of establishing the competence center, the very idea is to promote Industry 4 technology and to make it useful for the actual industry. And the Teaching Factory Competence Center has been established through the collaboration of LMS with a number of large companies in Greece as well as SMEs. So this gives the flavor and the nature of the center itself. The mission is to enable knowledge sharing among academia and the industry, and to actually, as I said, exploit research results towards industrial applicability in a number of application areas. It does it in two stages. One stage is skilling, upskilling, and training. So this has to do with training people in the industry on the basis of results achieved through research over the years. And then following this training approach, there is a stage of development and implementation of custom advanced technologies for the manufacturing industry based on the needs of the specific companies. There are two more things that maybe are useful to know about the approach of the Competence Center. On the one hand, it operates in 4 technology areas, namely digitalization, industrial automation. Second one being advanced manufacturing processes. Third one being AR, VR, and sensing technologies. And final one being platforms and communication technologies. And there are a number of services that are actually being delivered, implementing the overall mission and vision, being training services, as I said before, technical services, consulting services, and the last and most relevant being the EIT manufacturing services, trying to link industry to the ecosystem of EIT manufacturing. So all in all, this is the idea of the Teaching Factory Competence Center, and this is what we are actually running.
Very much, Sotiris, for telling us that background. And now let's go to the industry side and to the challenge owners. Giuseppe, you yourself were part of the Teaching Factories competition this year, presenting a challenge to create nature-based, pure and quiet air for working environments. So this is not the first initiative that Clean Air has actually taken to promote green manufacturing. I'm wondering, tell us just how useful was this? So, Giuseppe, can you please turn your microphone on? Sorry, we can't hear you yet. Let's take another go at that answer.
Apologies.
No worries, no worries.
I suppose now it's okay.
Yep, can hear you perfectly.
Thank you very much, first of all. Thank you very much, first of all. A great opportunity to extend our networking, also the activities on the field. We are very satisfied of this activity with the University of Pisa, with EIT Manufacturing. We are working strictly jointly since a couple of years in practice. Our initiative is strongly involved in practice since the end of 2016. Now we are moving our solutions also for the interior spaces, buildings, offices, and part of the industries close to the production, to the manufacturing areas. With the activities, we think we can improve strongly the solutions and the products. We are involved now in an advanced discussion with Amazon for the commercialization. Also, on the other part of the agreements with players and business partners. We are working on a couple of additional projects, and we think that in cooperation continuously with the University of Pisa and also with the other entities and university, because we are working also on the improvements connected to the consumption of water, because our solution, our pollution absorber, is versatile, nature-based, because it uses only water, simple water. And in this way, it's possible to apply everywhere, similarly to the air conditioning systems. If we think about that approximately 30 years ago, we can understand the value of a new solution to serve people on the other part of the environment with the purification of the air, the ambient air that we all breathe. So there is an enormous space of cooperation to create social value, not only business value. And we are very satisfied, very proud to continue to go ahead with these activities jointly. Thanks.
Okay, thank you very much for that intervention, and it's good to know that collaboration was very successful. Let's go over to you, Alisa Zaccaria, because you with Intellimec, you were also part of the competition trying to find a solution for the development of an online continuous quality inspection for electrical cable optimization. So that's quite a complex thing. Intellimec presented real industrial problems to these students. So how do you think this kind of challenge-based learning is helping them and can help them to improve their professional preparation?
Hi, good morning to everyone, and thank you for the opportunity. We have actually also really appreciated these initiatives since, well, our mission in Intellimec can be summarized in connecting research with industries. So we strongly believe in the opportunities connected with this link and with students coming into contact with real industrial problems. And well, I think that for their professional careers, this opportunity is extremely useful, especially since in academia you usually not consider the whole frame, let's say, no? In this real industrial problem, you have to face economical problems and also maybe cultural problems, which you don't consider when you practice basic research. So I think that this is the main important thing for them.
Thanks very much, Alisa, for that intervention. And so, Tiris, I'm going to come back to you because I guess what our audience also wants to know is what's the potential of this educational paradigm, as we're calling it, for the manufacturing industry, and what kinds of topics do you recommend for the upcoming competitions?
All right. That is quite challenging, but I will try to follow up.
Give it a try.
Yeah, sure. I think from the previous interventions, both from the pitching teams, also the questions of the jury, as well as the interventions from the colleague at the panel, we saw that the concept of the teaching factories is the unique opportunities is giving a unique opportunity to students and people in the academia to see real industrial problems in the full spectrum, not only technology and research-wide, but also economically and in terms of applicability and performance. Of course, also on the other side, it is helping also the industry to have a fresh look at the problems they have been facing over the years. For sure, they have optimized processes over the years, but the idea of coming and bringing them to discuss with new people is refreshing, I would say, and is helping to see things differently. Then there is another element that is key in the teaching factory concept, which is the combination of virtual and physical approaches. On the one hand, there is a virtual communication, virtual exchange of data, virtual modeling of the problem. So the whole virtualization exercise is helping to advance on the concept of doing things virtually and helping to advance technologies like AI or other advanced technologies faster. Of course, there is also the physical aspect, and this is why we saw in the competence center the idea of having a physical facility, which provides a reference facility that allows models developed virtually to be tested in an actual physical facility. So the idea of combining and first increasing the virtual aspects and then combining them with physical aspects is something that is standing and is materializing the idea of the teaching factory. Now, in terms of what exactly to do in the future, for sure, really trust the industry, knowing what exactly they would like to propose as topics. However, topics around advancing AI in different fronts, even that it may be challenging, can be a good opportunity for such a field. One may imagine trying AI in product, generating product designs, even that this might sound abstract. That could be a way to advance several processes in the industry. Also aspects relating to modeling, forming matter, forming material, producing different parts of different geometries. So I could see really a full spectrum of applications from an entire life cycle, from product design to production and then to circular aspects of the production. But I think the industry can have the first word for sure.
Okay. I'm not sure what kinds of topics the industry, our challenge owners, for instance, would like to see coming. Green manufacturing obviously has had quite a good response. Giuseppe, you could possibly comment on that, but I'd also like to ask you, after this experience with the Teaching Factories initiative, what would you like to say to other companies that are looking for novel solutions to problems?
It's the right place to find solutions, to find new applications, to see the problems, the issues, the needs from the field in the right place to solve, to understand, to solve, to work in a collaborative way. Very, very satisfied on our part and we trust for the next future jointly.
Thank you very much. And Alisa, let's come over to you, because we hear a lot about the labor and skills shortages that are set to cripple certain industries and certain industrial sectors. What would you say after this experience that IntelliMech has had with the Teaching Factories to other companies that are looking for skilled graduates to join their teams?
As well, I think that maybe students may not be the most expert people you can find in the world, but they are fresh, they have fresh ideas. And especially since they are not the most expert person in that field, but they can gain experience and they are not constrained by previous experience. So they are usually more ready to grasp the new opportunities and the innovations.
Okay, I'm still waiting for a list of the winners here. So Sotirios, I'm going to come back to you because I'd like you to tell me, for instance, if you were to be involved in the challenge presentation yourself, what did you see in these pitches here today in the presentation of dealing with kind of challenges that are related to green manufacturing that will best support the move to circular and sustainable manufacturing?
Yeah, I think all pitches have had a unique approach, each, and that's the challenging but also the great opportunity from this competition. I would not like to play the role of the jury board to say which approach maybe I would prioritize or do, but I really like the approach, the open-minded and out-of-the-box approach of all people trying to apply different approaches, whether it is sensors integration and controlling some process or doing measurements, or it has to do with modeling of the process and trying to quantify better. So I really think that there is a big potential, especially the aspect of bringing younger people and new people in problems that we have been discussing and being sometimes abstract or high level. So giving such a high level problem and trying to break it down to a more specific and to decompose into smaller problems gives you an opportunity to look at different challenges and apply different technologies. And giving focus to each one of them may be a way forward to solve these higher level problems. So it has to do, I think, the conclusion is more, it has to do with the people being involved, the skills they have, and the intensity they will try to apply specific technology, and it cannot be given as a high level that this is the way to go or the other way. It is really person specific and skill specific and also problem related sometimes.
Sotiris Makris, for giving us that supplementary information. And of course, I guess on behalf of all of us, we have to give another shout out to the jury of Renata Urbon and Virgil Pamphil and Sima Valizadeh. It was very clear that it was almost surprised. They really put the students and their solving teams through their paces, very paying very close attention there to what the students were providing. So that was, I think, a very well done session. Thanks to all of you for enlightening our audience on the Teaching Factories competition. And it is time to get back to our jury. I think I finally have the news that they have reached a verdict. So we'll find out who wins the top 3 prizes right after this.
Thank you.
And here we are back again, and we're going to finally have our award ceremony for the Teaching Factories competition. And I would like to ask Paola Fantini to join me on the stage here. I'm going to get Paola up here. And I think I have all kinds of people joining me now because I have Javier Gonzalez. So Paola, of course, everyone knows her as the Education Director of EIT Manufacturing. She's going to be joining me on stage. And Klaus Beetz, the CEO, coming on for his last appearance. Joining us still from Paris, virtually, unfortunately. Let's see if I can get Klaus online. And last but not least, and he's running through the room here, Javier Gonzalez is education developer at EIT Manufacturing. He was also very involved in this first edition of the Teaching Factories competition. Welcome, Javier. Very nice to have both of you on the stage here with me. Thanks for doing the honors on this, all of you. We're going to be presenting these awards. And I think, Klaus, we're just about to find out the winners. I do have a list, and I think you've also been delivered a list of the first Teaching Factories competition. What would you like to say to the industrial companies that participated in this first initiative? Because I think their participation was really appreciated. Klaus, can you turn your microphone on?
Yeah.
There we go. We can hear
Hello
you. Thank
again, here from Paris. Long time no see. So first of all, I want to say a big thank you to all the participants from the universities, from the industry, and of course, a special big thank you to the industry partners who shared with us their challenges they have in their daily work, in their factories and plants. And in my opinion, this Teaching Factory competition is really a win-win situation for both, for the industry, for the students, for the academia, for the professors, for the industry really to get inspired by newer ideas, getting from the student teams, by getting access to the students, to the talents, to get know them, and also for the academia and for the students to work on a real industrial challenges, creating opportunities for the young talents to know the real industrial processes, the real world, and contribute to generate innovative solutions. So me as the CEO of EIT Manufacturing, I'm very glad that we can facilitate this challenge-based learning. This will enhance the collaboration between industry and academia. And of course, it will enhance also our VCC. Karen, you know what a VCC is?
ECC is? European Economic Community is what I remember that being.
No, a VCC is a very cool community.
A VCC, very cool community. Thank you for enlightening on yet another acronym. I don't think anybody's better at acronyms than EIT Manufacturing. Thanks, Klaus. And yes, of course, they got a lot out of it, but they took a leap of faith in getting involved with this. So Paula, I'd like to ask you, what do you have to say to all the students who dove into this first Teaching Factories competition?
Yeah.
As well.
Well, first of all, congratulations, you have made it. You were enthusiastic, but also determined and perseverant. Exactly. So second thing that I would like to tell you is of course, good luck, best wishes, but especially I would like to tell you whether you are the winners or not. I think it could be helpful to make a reflection on what have you have learned from this experience. Maybe teamwork, problem setting, what maybe you need to improve for the future. And this, I think, is something that may help you for your CV, but also for developing your skill and having plans for the future. That's my suggestion.
Thanks very much for those suggestions. And I think that was a very useful session for all of the representatives of those teams involved. Now, we finally get to the moment that we've all been waiting for. And I am delighted to announce that I get to announce the winners this time. This is very unusual. And I have Paula and Javier here to deliver the trophies and the checks. And Klaus is in the background for moral support. So in third place, here we are. In third place is Fotis Basamakis. So congratulations to Fotis from the University of Patras. Let's get some clapping going here. We still have an audience. So Fotis, I hope you can see this online. Your trophy is being displayed. It's beautiful. I think we have a number of people from Patras here, and somebody's going to be able to bring that back to you. And you've also got a check for 500 euros. Made out to the University of Patras in Greece to help you continue on your way with further research projects. Thank you so much. Congratulations. And would you like to say a word or two on this honor?
Yes, it was, first of all, I want to thank Teaching Factors competition. It was a really nice experience. Me and my team was getting along and try to construct the problem and how to find a solution for it. So it's basically, it was nice because we get to work together and we experience how it will be later on after we finish our school, like a project. And also we search for state-of-the-art solution to the project to find the best approach. We make we put a lot of effort actually to it. It was a really nice experience.
As I think all the teams did. Thank you very much. It shows that you put a lot of effort into it, and I know that this virtual situation is hardly easy. Let's hope we can possibly also do the Teaching Factories competition in person next time. But thank you very much for being part of the first one, and congratulations to you and your team. Take that with you. So we will proceed on to the second place winner, who is Filip Sentkiralji. I am having a really hard time with that Croatian name. Filip, let's get you onto the screen. Fantastic work. Great job. You had to go first. So that definitely wasn't easy. And I hope you can see here, you've also got a second place trophy, which will be sent to you to put on your mantelpiece, and a check that Javier is holding up of 1,000 euros to put towards your further research and academics. And congratulations to you from all of us who are still here in the studio in Brussels, and from all of the online audience. Do you have a couple of words to say?
Well, first of all, I would like to thank you all for this experience. It was absolutely amazing, and it helped me a lot, not only in right now, but also it will help you a lot in future competitions and/or jobs. I would also like to thank my teacher and my teammates.
That's very good, and I think that deserves a round of applause, because we were kind of a bit short on the applause for you, Filip. Thank you very much for joining us. And finally, last but not least, in first place is David Todt from the ELTE Information Karsava. I can't read the title anymore. Unfortunately, it's gone too fast. Where is David? He's on the screen. Congratulations. You are our first place winner of the very first Teaching Factories competition. Let's have a round of applause from our studio audience here in Brussels. Everybody has listened very attentively to all of your presentations, and you've also got a trophy here that Paula is holding, and a check for 2,000 euros to put towards your future endeavors and future research. And would you please do us the honor of saying a few words on this great honor that you've experienced here today?
Yes, thank you very much. It's a pleasure for us to participate in this competition. It was a little bit hard for us because 4 of out of 5 members are BSc students who are working their thesis right now. We have to finish it in a month, I guess. It was really nice to see a real life problem from a company. I hope we made a nice job there. And I would like to congratulate for the teams as well, because I know that they worked hard as well, just like us. Thank you very much.
Exactly. Everybody worked very hard. A round of applause again for David Todt. And please take our congratulations here in Brussels back to your team members, and all the best for the future. And of course, everybody thinks that's the end, but it's not, because we had such a good turnout with all of these pitches that we've got a special mention, and I'm going to ask Javier to present this make this special mention and present another check.
Exactly. So this is a 500 euros check that you see here from the St. Cyril and Methodius University of Macedonia, because of their commitment with the Agora space, or making questions. Their real good commitment with the challenges, and also regarding the gender balance in the team. So this is one of the teams with more women in the team. That is always a thing that we want to consider, and that's why we have decided to make this a special mention for this team from Macedonia. So congratulations to the team, and yeah, that's great.
A very nice gesture indeed. Congratulations to the team there, and congratulations to all of our Teaching Factory winners, and thank you very much to Paula and to Javier. And I guess, Paula, you're going to stay on stage with me, aren't you? Because we're going to carry on here and bring Klaus back onto the screen. Teaching Factory competitions, obviously, surely to be continued. I think a successful first round. We've reached the end of this summit, the third annual EIT Manufacturing Summit in 2022. We started out a long time ago in a tiny little room in Berlin, Klaus. I remember when you came up to see me, and it was freezing. This has been 2 really exciting days. And I'm going to turn to Paula first, and then give you the last word on the end of this summit, because Paula, perhaps final words from you on this competition and the future that you see, the potential also for this Teaching Factories competition, because it's really been an event.
Yes, thank you, Karin. Of course, we believe a lot in this initiative. This was the first edition. This is not the end. So this is a message for the challenge owners, for the solver teams, for the university. Let's continue the collaboration. If there is sparks of enthusiasm in what you have started already, we can still support and go ahead. And we will have, of course, new editions in last year, and we hope to see more challenges, more solving teams, more multidisciplinary teams. This is, I think, our expectation for the future. And of course, yes, consequences that are impact on the industry, and a lot of success and career for the students.
Keeping up those great connections with industry as well. So Klaus, it's the end of the third summit, as I was just saying. And can you sum up your feelings after this one? You've unfortunately had to participate remotely, but I know you took a lot of it in. Tell us your thoughts and what's in the pipeline for the future. Klaus, can you turn the microphone back on? You muted yourself again. Sorry.
Sorry, I was on go. Yeah, what for 2 days it was. Yeah, very, very impressive for me. And it started with our panel discussion in the first day, and it was great to see for me that almost in all the panels we agree to look at circularity, at the transition towards the circular economy, more as an opportunity than as a challenge for the European manufacturing industry. And also, we concluded that skills are needed to fill the manufacturing industry, where CO2 reduction or CO2 decreasing and the movements toward the circularity is a priority, which leads also us to the deep tech as a means of reskilling. And we have seen here with the Teaching Factory competition that we have a lot of young people that are really interested in the deep tech, and I hope we can even more stimulate to find interest in these technologies. Then what was for me also important, the importance of looking at a whole entire value chain, that this was emphasized, since circularity could be only work if all actors are part of the development. And we have to integrate not only circularity, the whole sustainability, the decreasing of our energy consumption, the increasing of the reuse of prefabricated and raw materials into all our thinking, all our methods, all our technologies. You know, manufacturing was over decades driven by the triangle of cost, quality, and time. And we have to look at sustainability on the same level as we are looking at cost, quality, and time. So also in the breakout rooms, I'm always impressed by the richness of our community, by the solutions, by the impact we make with our projects there, with our activities. And finally, today we had the pleasure of awarding the risk leaders, the women leaders from the risk countries and the teaching factory finalists. So again, what 2 days? To conclude, I'm very glad to share with you an update on our Agora, our open innovation platform, which will be opening a new sphere dedicated to green and circular. This new sphere is launched as part of the overall movements toward more thematic and dedicated communities on Agora. We want to bring here really together 4 specific topics, the experts and all the European manufacturing players to discuss, to share ideas, to discuss especially sustainability challenges and solutions with this new sphere to co-create environmental sustainability impact, to share news, opportunities, guidance. So this is the first step with this new sphere. We plan other spheres and other topics as well. So if you are not yet there, join us on Agora, be active, network, share your ideas, take part in the discussions. You know, a community always lives from the participants, from the active participation of the members of the community. So with that, I thank especially the organizers team behind the scene.
Oh, round of applause for them. Yes, absolutely.
Yeah, so a big applause for the team behind the scene, the technicians, our marketing and communication team. I think they did an excellent job. And also the people who have been in the audience and who have been listening remotely. Thanks for your participation. I hope you enjoyed the next days. And I'm looking forward to see you next year again in the EIT Manufacturing Summit in the 23 edition.
Thanks very much for that, Klaus. And thanks also to you, Paula, for being with us through thick and thin here for these 2 days. Very eventful 2 days. Great news about the new platform and absolutely great display of the innovative ideas and solutions that are out there to make European manufacturing more circular and more sustainable. That is all for this year, as Klaus has just said. So thanks very much to all of you out there in the cyberspace for joining us and making this 2022 edition a success. I will just remind you that all sessions will be made available in the replay in the coming days. With that, all the best to you and bonne continuation. We wish you all the best and hope to see you here next year. Bye-bye and ciao. Love from Brussels.